Okay, we are going to work on 5.6, the fundamental theorem of algebra, one learning target that you can use the fundamental theorem of algebra to determine the number of solutions a polynomial is going to have. Now, that is actually quite simple, so the majority of our work is actually going to be spent on factoring and solving, which we worked on in the previous two sections. Okay, the fundamental theorem of algebra essentially says that if I have a polynomial of degree n, and n is greater than 0, then the equation, when it's set equal to 0, has at least one solution in the set of complex numbers. Okay, a corollary to that is if f of x is a polynomial with degree n and n is greater than 0, then that equation, f of x, when it's set equal to 0, has exactly n number of solutions, provided that each solution repeated twice is counted as 2 solutions, and each solution repeated 3 times would count as 3 solutions, etc. Okay, so essentially what that means is you can just look at the degree of a polynomial, and that is how many solutions it's going to have. And that is what the fundamental theorem of algebra is. Okay, the first thing we want to look at is we want to use the fundamental theorem of algebra, and we want to determine how many solutions or roots an equation has, and then we want to find those solutions. Okay, so all you have to do is look at the degree. Okay, the degree for this equation happens to be 3. Therefore, I should have 3 solutions. Degree is 3, so I should have 3 solutions. That's the fundamental theorem of algebra. As simple as that. Okay, now like I said, the majority of our work is really solving, and those use methods previously used in 4 or 5.4 and 5.5. Okay, so I want to solve this. The first step is make sure it's set equal to 0. It is. So then we can go ahead to our factor flowchart here, and it says that we want to take out the greatest common factor. 1, 3, 16, and 48. No greatest common factor there, so I'm going to answer how many terms there are. 1, 2, 3, 4. There's 4 terms. So that means I can answer the question, does b divided by a equal d divided by c? b over a equal to d over c. So is 3 over 1 equal to 48 over 16? Well, 48 over 16 is 3, so these are all equal to 3. So the answer to that question is yes. Yes, they are. Okay, so since b over a is equal to d over c, that means I can use the box method of factoring. All right, so I'm going to go ahead and do this. Set up my box. All right, we're going to go ahead and put the x cubed term, the 3x squared term, the 16x term, and the 48. No negatives, so I don't really have to worry about where I'm pulling a negative out. Okay, so then I just take greatest common factor, so we're going to go 48 and 3x squared. Greatest common factor there is 3. 3 divides out of each of those. 16x and x cubed would just be an x. X cubed and 3x squared, that would be an x squared. And then 16x and 48, that would be 16. Okay, so we get x squared plus 16 times x plus 3. Okay. And again, all we're doing there is just taking out the greatest common factor, which we have done a lot in chapter 4. And then we've actually kind of done that a lot already in this section. Okay, and so then now I just have to take a look at each of these factors and identify whether or not those can be factored further. So I'm looking at this one, and those are neither perfect squares nor perfect cubes, so that tells me that those are not a special pattern, because I'm only looking for special patterns because there's only 2 terms. Here, though, these are each perfect squares. X squared is a perfect square. 16 is also a perfect square, meaning that I might have a special pattern. But upon further inspection, I'm adding these, and there's only a difference of perfect squares, and this is a sum of perfect squares. So from this point on, I can just solve. All right. Okay, so I'm going to subtract 16 from each side here and get x squared is equal to negative 16. To get the x by itself, I would have to square root each side. So I'm going to go ahead and do that. Okay, then I get x is equal to, now you're going to have to remember from chapter 4, we get the square root of negative numbers we can do now, and that is going to involve I. So the square root of 16 is 4. The square root of that negative is I, so this is going to be plus or minus 4I. Okay, and then here I'm going to go ahead and subtract 3. And we're done. Now, here's the thing, though. As I look back, the fundamental theorem of algebra told me I should have 3 answers. And it looks like I only have 2, so that is a little bit of a problem. Well, fortunately, we know we have clearly one solution here. But when I look at plus or minus 4i, that's actually 2 solutions because there's positive 4i and a negative 4i. So there's actually 2 solutions here. In total, 1 solution, 2 solutions, 3 solutions altogether. So that fits firmly into the fundamental theorem of algebra. Okay, so everything after the fundamental theorem of algebra is review. So this is a great opportunity for those who struggled with the previous stuff to get better at it, and those who felt like they did well on that kind of work to get a little bit better. Okay, I think everybody should pause the video now and try A on their own and check it with me when you are done right now. Okay, so this is not set equal to 0, but if I want to find solutions or roots, if I'm going to find roots, that means I need to have this set equal to 0. Plus 12x squared plus 8x. Okay. Now to find my greatest, or to solve these problems, I have to follow my flowchart, and that's calling for taking out the greatest common factor. So I'm going to go ahead and take out the greatest common factor. It looks like they each have an x in common. Okay. Now when I'm looking at this, 1, 2, 3, 4, I have 4 terms. Okay, when I have 4 terms, I have to ask whether b divided by a is equal to d divided by c. So 6 over 1 and 8 over 12. No, those are not. So 6 over 1 is not equal to 8 over 12. This means I have to use synthetic division. Okay, so I have to use synthetic division, which follows a 4-step process. Okay, so that means the first thing I need to do is find the number, the possible solutions. So the possible solutions are the last term divided by the first term. So that means positive or negative 8. Positive or negative 4, positive or negative 2, and positive or negative 1. Any one of these could be solutions, and I am not really interested in guessing and checking which one of those could be a solution. As opposed to that, I'm just going to use the calculator. Okay, so we're going to go ahead and get our calculator out, and we're going to write this equation into the y equals. So we are going to go ahead and get x to the third plus 6x squared plus 12x plus 8. And we're going to graph that. Okay, looks like probably negative 2. Okay, so we think x equals negative 2 is a root. Therefore, I believe that x plus 2 is a factor. Okay, and as you can see here, it only goes through this x-axis one time. And so that is why in the previous sections I was telling you very clearly that you can't just take the factors off of those and just write it, because sometimes we're going to have complex solutions, which you're going to see here. Okay, so here then I can go ahead and divide. Okay, so I am going to go ahead and divide x plus 2 by this polynomial. We're going to get 1, 6, 12, and 8. Drop the 1. Negative 2 times 1 is negative 2. And that's 4. That is negative 8. That's also 4. And then that is going to be negative 8 as well to get 0. Okay, and if you recall, this is very good news, because the remainder is 0, meaning that x plus 2 is indeed a factor. So we picked the right factor there. So now what we have is x times x plus 2 times remainder constant x squared plus 4x plus 4. Okay. And so then here I can look at this and I got to figure out how I'm going to factor that. So I have 1, 2, 3 terms. I have 3 terms, and does my a value equal 1? Yes, it does. It does equal 1. So I can look for values. Since it equals 1, yes, I can find numbers that multiply to c and add to b. Okay, so numbers that multiply to 4 and add to 4, that's 2 and 2. Okay, and then lastly, we can find solutions. Okay, so this is repeated, so we can just go x times x plus 2 squared, or cubed. All right, and so that means x is equal to 0, or x plus 2 is equal to 0. Means x is equal to negative 2. Okay, now here, now here is a very particular one, right? Because we clearly only have like 2 answers, right? We only have 2 answers. But as you read the corollary to the fundamental theorem of algebra, that each solution repeated twice is counted as 2 solutions. And each solution repeated 3 times is counted as 3 solutions. This factor occurred 3 times. Since this occurred 3 times, we can count this as 3 solutions. This is 1 solution. So all in all, I have 4 solutions, which is consistent because my degree here is 4, meaning I should have 4 solutions. Okay, so this is, my degree is 4, so I should have 4 solutions. All in all, when we use the corollary to the fundamental theorem of algebra, we determine that this should count as 3 solutions because it has 3 factors. Okay, let's go ahead and move on to the next section, or the next page. I think this is actually the last page. It is. Okay, so what about problems like this? We want to find all zeros of these polynomials, meaning I want to find when it's set equal to 0. Okay, I have a degree of 5. So that means when I'm all said and done, I should have 5 solutions based on the fundamental theorem of algebra. Okay, so let's go ahead and solve this. Okay, greatest common factor. Looks to me that I don't have any. So now I have 1, 2, 3, 4, 5 terms. I have 5 terms. This is our first 5-term one. So how many terms are there? There are 5 or more terms, 5 plus terms. Anytime there's 5 or plus terms, there's not really a nice gimmicky way to get through it. We just have to use synthetic division. Okay. So we can use synthetic division, so that means I can look at the last term divided by the first term, okay, which is 8. So all of these different values could be solutions, okay, could be real solutions, and we just got to find one, okay, and so there's only one way to do that, and that is get the calculator out. Okay, so we are going to go ahead and type this equation in. So we're going x to the 5th power plus x to the 3rd minus 2x squared minus 12x minus 8. Okay, and to go to a power other than 3, so you can go the caret symbol, that little up arrow, that means x to the 5th is right here. It is right below the clear button. Okay, and then we can hit graph. I'm looking at this. Okay, looks like we have a couple different answers. It looks like -1 and 2 appear to be where it crosses the x-axis. So I could pick either of those. I'm much more confident in this x being at 2 than that one being at -1. So I'm going to go at x is equal to 2. So I believe x equals 2 is a solution. Or 0 or root, whatever you want to call it. We're referring to zeros here, so I'm just going to go with 0. So if x equals 2 is a 0, that means I believe that x minus 2 is a factor. Okay, so I can go ahead and divide out x minus 2. So I'm going to put a 2 here. And then I'm going to put 1, and then I have to put a 0 here. How come? If you recall from synthetic division, we're going to go from highest degree to lowest degree, and you need to include all degrees. This one is missing a degree of 4, and so that means it's 0x to the 4th. And then x to the 3rd, x to the 2nd, x to the 1st constant value. Okay, and so I can go ahead and drop this down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 1 and 4 is 5. 2 times 5 is 10. Negative 2 and 10 is negative or positive 8. 8 and that, 8 and 2 is 16. Negative 12 and 16 is 4. 2 times 4 is 8. Negative 8 and 8 is 0. And that's my remainder, so this is good. Okay, so that means we just divide it. So this is constant x, x squared, x cubed, x to the 4th. Okay, and so I did all this work, and so I factored out x minus 2. And what my result is x to the 4th plus 2x cubed. 2x cubed plus 5x squared plus 8x plus 4. Okay, so then, oh, this is like my third step, right? And my third step is just factor. So I can't factor this anymore, but now I can factor this. Okay, and I have 1, 2, 3, 4, 5 plus terms. This is going to be a little bit of the downfall of the process of synthetic division, is it's not going to factor it completely. It's only going to take one factor out, and then you have to reevaluate, and constantly you're going to have to keep going in this cycle of, can it be factored, can it be factored, can it be factored, how can I factor it? And it might take several steps. So here I need to factor this, and I have 5 terms. Okay, so since I have 5 terms, I'm going to have to use synthetic division. Okay, so we can kind of start over. That's kind of what it feels like, right? We're starting all over again, but we do have one factor taken out. Okay, this one, a term divided by b term, or last term divided by first term is 4. So that means my possible solutions are much smaller at this point here. Okay, so let's go ahead and type this into the calculator. We're going to go x to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus 4. Then I'm graphing. So as I look at the graph here, all right, my best guess here is that is at -1. Okay, but -1 is a possible solution. Just like up here, we thought 2 was a solution and positive 2 was a possible solution. Since -1 is a possible solution and it looks like it's crossing at -1 or touching at -1, I think it's okay to go ahead and think that x equals -1 is a 0. Meaning that x plus 1 is a factor. Okay, so I can divide this polynomial by x plus 1. So 1, 2, 5, 8, 4. No 0 needed because there's no gaps in our polynomial. So I can drop this down and get 1. -1 times 1 is -1. 2 and -1 is 1. That's -1 also. And this 4. -1 times 4 is -4. 8 plus -4 is 4. -1 times 4 is -4. 4, negative 4 is 0. Okay, so it turns out that it does cross the x-axis at negative 1 because my remainder is 0. This is my constant term. This is my x term. This is my x squared term. This is my x cubed term. Okay, so now I have x minus 2 times x plus 1 times x cubed plus x squared plus 4x plus 4, and that is equal to 0. Okay, so these are each factored out. Now I can check how can I factor this. 1, 2, 3, 4 terms. 4 terms here. Does b over a equal d over c is the question I need to answer. So does 1 divided by 1 equal 4 divided by 4? It does. And that's good because that means we can kind of get off of the synthetic division terrain and we can start factoring in other methods because the other methods are just faster and easier. That's why we teach them to you. Otherwise, we would just teach you synthetic division from the get-go. And it looks like since b over a is equal to d over c, we can just use the box method. Okay, so let's go ahead and do that. So we're very much nearing the end of this problem. We're getting x cubed and x squared and 4x and 4. Greatest common factor here is 1. Greatest common factor here is x. Greatest common factor here is x squared. Greatest common factor here is 4. Okay, so we get x minus 2 times x plus 1 times x plus 1 times x squared plus 4. Okay. Then we need to check whether this can be factored further because I do identify those as perfect squares. They're both perfect squares, but I'm adding them, meaning it's not a special pattern, so they can't be factored. Okay, so I can rewrite this as x minus 2 times x plus 1 squared times x squared plus 4. Okay, so what can I do from this point on? I can just find the solutions. Okay, so we're going to get x minus 2 is equal to 0, so that means x is equal to 2. X plus 1 is equal to 0, so that means x is equal to negative 1. And then x squared plus 4 is equal to 0, meaning x squared is equal to negative 4. We square root each side to get x is equal to plus or minus 2i. Okay, so we have complex solutions. Now, all in all, my degree was 5, so I should have 5 solutions. Here's one solution. This is 2 solutions. Because x plus 1 was a repeated factor, so the root of that counts as 2. It's going to count for each of these factors. Okay, and then here, although this is one factor, this one is also going to count as 2 solutions because positive 2i and negative 2i are solutions. Okay, so that means that, again, these problems fit nice and neat into that fundamental theorem of algebra. Okay, these problems are a lot longer than the previous ones, but they're consistent with what we've been doing. Okay, you just have to understand that, like, once I divide out a factor, I can set that, times the other one, and we just need to recycle. Like, once we factor once, we need to recheck our work and see if it can factor again. Then once we take that, we need to check to see if it can be refactored again. Do that until it's completely factored, and then find the solutions. Okay, I am going to go ahead and let you all try B. Go ahead and pause the video and try this one on your own and go ahead and check it when you're done. So I'm finding the zeros, meaning I'm just finding the x values that make this equal to 0. Okay, I should get 5 solutions when I'm done because my degree is 5. All right, we need to find the possible solutions here. Now, this is negative 36, so that means over 1. So negative 36, that's half of that. And 18, and 9, and 12, and 6, and 4, and 3, and 2, and 1, okay? So look at all these different factors possible. These are all the different possible solutions. 2, 4, 6, 8, 10, 12, 14, 16, 8. There's like 18 different solutions here. or possible solutions. So again, you don't want to have to plug those in and figure out which ones make them equal to 0. Okay, that's going to be way too much work. That's why we have the calculator. So let's plug this into the calculator. Okay, so we're going to go x to the 5th plus 3x to the 4th plus 9x to the 3rd plus 23x squared. It looks like we're missing the regular x term, which is fine. So we're going to look at this here. It looks like we're crossing at -2 and at 1. I feel much more confident in 1 than I do in -2. And 1 is a possible solution, so we're going to go with that. So I think that x equals 1 is a 0, meaning that x minus 1 is a factor. Okay, so we can go ahead and divide this out. So we're going to get 1, 3, 9, 23, 0, -36. Okay. So 1, that's 1. This would be 4. 1 times 4 is 4. That's 13. That is 13. That's 36. 1 times 36 is 36. That's also 36. 1 times 36 is 36 again. And that's 0. Okay, so that's good. All right, so I did my synthetic division. So that means I'm going to get x minus 1 times x to the 4th plus x to the 3rd plus 13x squared plus 36x plus 36. And that's equal to 0. Okay, so it looks like I forgot to put a 4 here. X to the 4th plus 4x cubed, 13x squared, 36, and 36 here. So that should be a 4. So now what we can do is we need to reevaluate this and see how it can be factored. Okay, so I'm going to type that into the calculator. X to the 4th plus 4 x cubed plus 13x squared plus 36x plus 36. So I'm going to type that into the calculator. I'm going to hit graph. Okay, and this time it looks like it's crossing -2. Okay, so I believe that x equals -2 is a solution, which means that I believe that x plus 2 is a factor. Okay, so I'm going to divide out x plus 2. 1, 4, 13, 36, 36. No missing terms, so no 0 needed. I'm going to go ahead and drop 1 to get 1. -2 times 1 is -2. That's positive 2. -2 times -2 is -4. That's 9. -2 times -9 is -18. That's 18. -2 times 18 is -36, which is 0. Perfect. So this is my remainder, which is good. Constant x squared, x cubed. And then I can go ahead and get x minus 1 times x plus 2 times x cubed plus 2x squared plus 9x plus 18. Okay, and so then as I'm looking at this last term here, I got 4 terms, 1, 2, 3, 4. Okay, and I need to identify how I'm going to factor that. And so the question I ask myself when I have 4 terms is b over a equal to d over c. 2 over 1 and 18 over 9? Yes. So I can use the box method. Okay, x cubed, 2x squared, 9x, and 18. Greatest common factor here is 2. Greatest common factor here is x. Greatest common factor here is x squared. Greatest common factor here is 9. So this is going to factor into x minus 1 times x plus 2 times another x plus 2 times x squared plus 9 is equal to 0. Well, I have a repeated term here, so let's go ahead and condense that. All right, so I have a repeated term here, so I went ahead and condensed that. And so then lastly, I can just go ahead and actually find my solutions. So I know x minus 1 is going to be equal to 0. That means x is equal to 1. Okay, and then I have x plus 2. That can be equal to 0, so that means x is equal to negative 2. And then lastly, x squared plus 9 is equal to 0, meaning x squared is equal to negative 9. Root each side to get x is equal to plus or minus 3i. I know I should have 3 solutions, and this is one of them. This is 2 of them, because I have a repeated factor of x plus 2 here. And then lastly, x squared is equal to, or x plus is equal to plus or minus 3i. That's 2 solutions also. One is plus 3i, and the other is minus 3i. Altogether, having 5 solutions. Okay, so quite a bit more work in terms of the problems that we actually have to solve, but that process ultimately is the same.